So, Raghu, you're trying to install Cloudera VM or VM provided by Simplilearn? Okay, I think you need to just reformat everything and install it. There may be some minor problems, so just delete everything and reinstall it. Should work. Okay. All right. So, all of you, on the Friday, we actually discussed on how to write a Mapreduce program. We wrote our first Mapreduce program to solve word count problem, and then we also worked on combiner. We understood how a combiner can be used. By the way, what is the use of combiner? Can anyone tell me? Yes, that's correct actually. So it basically reduce the network traffic by implementing the reducer code at a mapper level, at an output of local mapper level, right? And that way you are basically trying to reduce the network traffic so that less number of bytes will be transferred over a network to the shuffle and sort phase. That's how we can improve the performance on the Mapreduce program by using a combiner. And combiner can only be used where your final output is not going to change. If your final output is going to change, then it cannot be used. Okay. All right. So let me start writing one Mapreduce program. I'll show you one example where we will. It's like we'll try to solve one more Mapreduce program, uh, which will really give you good experience on how to start thinking in a Mapreduce way. How do you decide which is the key and a value for solving this Mapreduce program? Okay, so that is very important. Whenever you are trying to solve any Mapreduce program, you need to understand which one will be a key and which one will be a value for your mapper and reducer. For example, let's say we need to go to the, let's say there is a transaction data. I'll first show you the data and then I'll show you the problem statement. So this is the data set, and I want to process this data set to solve one problem. First of all, what does this data set look like and what does it do? So it does this part. Basically, it has a transaction ID, it has a transaction date, user ID, amount, product, city, and payment mode. Which means if you look at the first any one of the line, it says that user ID 400100 has done a transaction of $100 to buy this particular product from this category, exercise and fitness. It's actually a product category, but we refer it as product only. To buy this product from this city on this particular date, and the mode of payment was credit card. Okay, so that is how you can interpret this record. So let's say we have this transaction record and we want to solve one problem where I want to find out the maximum transaction done for a given product in a given city. So if you look at this example, I have the first two records. If you see, there was a product and the city. Exercise and fitness is a product and the city is Clarksville. In the second record also, these two are the ones, right? I mean, the first records, user has spent $100 to buy some product in this category on this city, and the second record, user has spent $2,000 to buy one product in this category in the same city. So as you can see, both of this record will have the same product and city combination, but amount is different. So you just need to tell me in the final report that, okay, for this product city combination, amount is 2000, which is the highest, right? If you take another example, let's say water sports is a product which was bought in Columbus City. Similarly, there is another water sports and Columbus City combination is there. For first record, it was 415, second record, it is $500. So 500 is the maximum. So you just need to print every such combination where what is the maximum amount which was spent for a given product in a given city. That is what we want in a final report. So is everyone clear with the problem statement? Okay, so with that actually, if you want to solve that problem, can you now tell me what is the key and the value of mapper and reducer? For example, something like this. Basically, you have a mapper code, right? And you need to just give me the input and output key value. No, not like that. Input key value, output key and value. And similarly for reducer also, you need to give me input key value and output key value. So as you can see, right, our entire Mapreduce program will always contain data in the form of keys and values, right? The data will flow in this format only. So we need to, before we solve any problem, we need to first decide what should be the key value for my mapper as well as reducer. If you can do that, then your Mapreduce program becomes very easy to write. I mean, you can easily do that. Right. So here, the input key, output key is like, I think almost same for most of the programs because it's byte offset. I think it's not readable. Let me just delete it. Byte offset is the key and entire record is the value. Right. That is your input key and input value. But what should be the output key and output value for this problem if you want to solve this problem? Can you tell me? I got one response. How about others? Yeah, so basically here the product city combination. See, if you look at here, I want the maximum transaction done for a given product and given city, right? So to understand that, I need basically both this data, right? Some of you have told that only product or only city as a key and the amount is value, but then I need both of this data, right? So I need to have a key or a value which contains all of them, which means my key should be the key output key value of the mapper should be product and city combination and the value should be amount. That is what I am going to write as a key and value from the mapper, right? So let me explain you how does it work. So basically, let's say I'll take just 2-3 records example and show you how does it work. So let's say this is your mapper output. In that you have exercise and fitness and Clarksville, right? Clarksville is a city. You can actually separate them with some underscore. This is my key. The value is 100. Again, there is a second record for the same two combination. This time the value is $2,000, right? And then you have another record called water sports, Columbus, water sports, Columbus, 415 and $500. So as you can see here, this combination also, the data will be in this way. Now this is your output of mapper. Now in shuffle and sort, what happens? It will combine all the values of the same key, right? So exercise and fitness class will A. If you see, all the values like 100 and 2000 are basically combined here. Similarly, here also water sports and Columbus is a key, and the value is 415 and 500. When it goes to reducer, what happens? You are taking this as a key and this is a list of values. Now you can easily write, right, that the output key will be this and the value will be 2000. This is your final output which I expect, right? So that's how basically your problem will get processed if you take the right keys and values. Now, whenever you take a key and value, you need to also think in these manners, like how it flows in the different stages of map and reduce. If you can start understanding it in this manner, you yourself can only validate like whether you have taken the right key or value. Okay, this is called thinking in a Mapreduce way. Are we all clear with that? So basically, Nitin, what I'm expecting is I want a maximum of both this value, not the sum of both this value, right? So if I get all this value as a list, then in reducer I'll just iterate through them and find the maximum amount. That is what I wanted. Clear? Yeah. Anybody has any more doubts on this? Yes, Raj. So it's a good point. Now, can you tell me, can we use a combiner in this scenario or not? Yes, that's right. Combiner can be used here, okay? It will not impact anything because you are just getting maximum. So maximum will not change the output. All right, good. So let us start writing a program for this. So I'll create a new class. As we know, every Mapreduce program will need to have a reducer, mapper, and a driver. So in the mapper class, this is what we are going to do. This is what you are going to write, right? The input key is a byte offset, the value is the entire record. Similarly, output key is a product city combination, the value is 100. So how are you going to map this? You will need to basically select the appropriate type, right? And I'm just selecting the appropriate type here for the keys and values. I'm choosing the right text object. So this completes the structure of my mapper class. Is everyone clear? Any doubts on this portion which I have written? Okay. So now I'll be writing the program here. I'm creating an output key and output value object where I have to set the outputs. Now once I get this record, I need to basically this is the record that I'm getting. I need to split that. I need to just say toString dot split, comma, will give me array of columns. Okay. So each of these column is separated by comma, so I'm just getting it in the form of array. Then you just need to set what is the key. The key is product. Product and city is the combination of these two is what I need to take it as a key, which are separated by underscore. So I should take that. Nikhil, it is zero base indexed. Any array is. That's why we should take this way. And amount I need to convert it from string into the array. Okay. Shantanu, underscore it's optional. You can put, you cannot put. It's like, it's like your wish, but then I have put it because just to segregate that product and city are two different things. That's it. You can just avoid it. You don't really need to write it. You can just avoid it. It's fine. So, Mary, in that case, if you have multiple columns and if you don't know the order, then in that case, what people do is they will have a separate property file where they define the mapping between column names and column numbers, right? So you can read that property file in your code, and then from there you identify whether this is your first column or second column. Okay, so that is not a concept of Mapreduce. That is a normal programming. How do you handle it using programs? All right. So is everyone clear with this? This is a mapper code. Any questions on mapper code? So Mary, parseInt is a Java concept. So basically it will help you to convert any string into the integer. Okay. So here I am reading every column as a string. So I'm reading this 100 value as also string, but I need to convert it into integer. That's what I'm doing here, because output type is intritable for me, right? I'm storing it as an integer. That's why I want to convert that data from string into the integer. Okay, we can start writing a reducer now. This is what you get. The key is a product and city combination. The value is this list of amounts. And the output you are writing it as a maximum amount which you spend. So again, how do you define this? Key is text. See, reducer's input key input value is very simple. It's like whatever is the output key and value from the mapper, the same data type you can use for reducer's input key and value. So there is not much change there. Okay. Now here also we need to write a reduce method to override the reducer functionality. Now I need to take the maximum, right? Just taking, let's say, maximum variable, and I'll have to, it's like normal array. You have list of values, you need to find a maximum. That's the problem you are trying to solve. So for every values, you just say if max is less than each value, then I'm assigning that value to the max variable. Okay. And then at the end, I will have a final max variable which will be the maximum, which will contain the maximum data. And you can do this context.write key value. Okay, here you can also, this should be fine. I can take this as a text. Why text? Because I can actually add some message also that max amount is this, something like this. Okay. So are we clear with the reducer code? Any doubts? Yeah, actually, Mary, I'm writing this actually. As you can see, I'm appending some string also. So this is my entire output key, output value. That's why it is a text. We already have a context object, right, Nikhil? Where are we missing comma? No, it's 3 only. Okay. So let us continue writing the driver code. As you can see, the driver code is something where we need to basically write only the configuration classes. we need to import the right objects here. So we have created a configuration and a job object. Now we'll do job dot set of mapper class, set jar by class. All these properties you can use here. I'm actually setting the output key type and value type of the mapper as well as the reducer, right? So this is standard. After that, you need to check what is the input format. So file input format class. You should not add input, the job, and you will say new path. Okay. So I have given two paths like input path and output path from the command line. So input path will be processed by file input format, and output path will be processed by file output format. Okay. And after that, the last one is basically okay. So what you are setting is job dot wait for completion, which means you are submitting the job to the job tracker, right? And it gives a status as 0 when it is successful. Otherwise, it is giving as 1 when it is failed. So we are able to complete rewriting the entire Mapreduce program, which has a mapper code, reducer code, and a driver code to solve the problem of finding a maximum transaction amount for a given product and city combination. So is everyone clear with this code? Any doubts on this code? This is a map function and this is a reduce function. So what you are doing in mapper class, you take this as a key, this as a value, split that record into columns and set appropriate columns as a key and value and write it into the output file. That is what you are doing in a mapper class. I mean, ideally you should not get trash, but if you get, then programmatically you can handle it, right? If it contains all the characters and all, something like that. So this is a programming challenge. I mean, so that can be easily handled. Unless it is specific to Mapreduce, then other stuff we can easily handle in program. You can just check if if it contains header, like if it contains all the text, or if one of the header name you can just check if that line contains this kind of value. Then don't process anything, don't do anything, don't write anything. Skip that record. Nikhil, I have a sincere request to everyone, in fact, not to you only. Whoever doesn't know what is, doesn't have any background in Java, then I would not be able to help you understand much concepts in Java in this session. For that, you have two options. One is you can go join Simply Learn community, right? Simply Talk is the community that we launched. You can ask questions there, or you can learn a lot of references will be shared there. And there is a self-paced Java learning courses available from Simplilearn. It's free of the charge, I guess, all for all of you. So you can actually try exploring your Java skills based on that. So it's a Java videos, and it has explained all these concepts from the basics, right? Whichever you need to know for Hadoop. So I feel everyone should go through that rather than trying to learn in here itself, because here I would not be able to explain each and every concepts of Java. Okay, so I would really sincerely request that if you can start learning those concepts from the external classes, then it would really help you. Is it fine, Nikhil? Because these questions like what does public void map does, or what does this static class does, then it would be really difficult to understand, explain that part right now. And because these are very basic for any programming language. All right. So let us go ahead and start creating a jar file. So I'll go to the project, I'll export that as a jar file. I've created a Mapreduce.jar. That is mr.jar available. So I need to use that. I'll also check if I have a transaction data available. Yes, transaction data is already available. So I can use it. So directly I can write a jar command to execute a jar file. Okay. So I have given the input path and the output path. Input path is a transaction file, output path is this. So let us execute this and see how does it give the result. Yes, Nitin, actually, I'm running too many other services, that's why. That is Vishal, actually there is something called tool interface. So instead of using this command line arguments, you can use tool interface to pass the arguments. It's actually ignorable. Nothing much on that. Okay. So there is a transaction out and we got the data. So let us go and check. So as you can see, we got the maximum transaction for every city product combination. Okay. These two examples we have given, exercise fitness and Clarksville 2000. Water sports Columbus, we got it for 500, right? So likewise, there are other product city combination which also we got for the, which has a maximum transaction spent. So that's how we can solve Mapreduce programs. I hope everyone is clear now. We will take many more examples to understand different concepts in Mapreduce, but this is just a starting point, and that's why I've given you one more example which you can understand to practice it more. So any doubts on this? No, no, Vishal. So actually, there is a tool interface class which component which we can set it in the uh, sorry, in the code itself here in the driver code, so that you don't need to pass those parameters as an argument of 0 and 1. You can just set it in the tool interface. It's a way of passing the command line arguments like input and output path. That's it. Okay. Yeah, Nitin. So don't worry. As I said, there are a couple of more Mapreduce programs we'll be learning in coming up sessions, because we have to learn so many concepts also. So I'll be taking those programs, and that way you can understand like which one is a key value. Like you will have a good practice on that. Okay. Now, can anyone tell me how do you see the log files for this program? I have shown you that. Can you hear me, guys? Hello. Can you hear me? Hello, everyone. Can you hear me? Looks like my presenter rights have been revoked. Unfortunately, something happened and now I cannot share my screen. So I have to just check with Simplian team again. Just give me a minute. I'm checking with them. Yeah, looks like I'm requesting them, but nobody's responding. Let me just give me 1 minute. I have to call them. Okay, so looks like I got the control back. Okay, let me just share the screen. Is everyone able to see my screen? Okay. So now you guys tell me, like, how do you see the log files for this? Like I have shown you, right? So do you remember how to see the log files for this program? We need to go to the YARN Resource Manager, right? And there will be a list of applications which are listed here, as you can see. One of them will be a job which you have written max transaction job. Correct. So that is the job which I have given here, the job name in the driver program. So based on that, you can easily identify. So that is a max transaction job, and in that you can actually check the history where you can go and see the job details basically. Like what was it, when did it started, what is the status, how much time it took to run, all this particular stuff. And yeah, you can go to the mapper and reducer class, the mapper where you can see the logs for map class, and the reducer where you can see the logs for the reduce class. Okay. Now I'll also give you, like, let us add some sysout statements. I'm just printing something in the mapper and something I'm printing it in the reducer. We just wanted to see the logs which are being appeared here or not. Okay. Now if I print these logs and if I let me just rerun it quickly, this change which I have done. So if we do this, by the way, you all know, right, that the output folder which we give has to be the new output folder where the output should be written. What if I will give the same output? Let's say transaction output was already there for the last execution that we had. We have given the transaction out as the folder name or a directory name where output file was written. Now if I give the same again, then yes, Vishal, you are right. So it will give an error because of the worm, right? Once read many times. As you can see, it says transaction out already exists, right? So that is the reason why we need to always give a new output directory. Yes, Nitin, we can do that. I'll show you that. So again, the job is completed. The output should have been generated. But let us go to the Yarn Resource Manager and check the output. So we will see the output here. As you can see, there is a map task. You need to open the task ID. It will show you which machine it is executed and what is the log file. So here, as you can see, it gives you the mapper code, which means it prints the mapper code message, which we have printed from the mapper class, right? In the standard output section. Why it has printed so many times? Because that many lines mapper class has processed, right? That many number of lines map method has run. That's why we are printing this many number of times mapper code. And then the reducer class, here also you can see the reducer code, which are basically the output that we have written from the reduce method. Okay, that's how we can see we can troubleshoot the Mapreduce using log files. Where it is possible, you can write Mapreduce using Python also. Okay, now let me show you the way we can debug Mapreduce program. Okay, see, I have helped you understand how do you troubleshoot Mapreduce using log files, but how do you debug it using Eclipse itself? Runtime debugging. That is what we are going to learn. Okay, does anyone know what is a debugging? Or I would say, does everyone know what is debugging? Anybody who doesn't know debugging or have never done debugging earlier? Yeah, Nikhil. So basically, I'm just asking like if someone has tried debugging or not through Eclipse or through, if you had used some other languages, programming languages, in that language also, I'm sure you would have done some debugging. That is what I meant by debugging actually. So in Java or in Mapreduce also you can use debugging, and you can, you know, understand each and every execution of map or reduce what is happening behind the scenes. It helps you to resolve some of the bugs very quickly. Okay, so let us set a debugger here. To set a debugger, first of all, you need to import all the jars. I need to go to build path, configure build path, and you need to basically add external jars where I'm going to add all the jars from client 020 folder. Okay, I'll select everything and just OK. Click on OK. So it will basically be available in the library section. So it is all of these jars are basically added as a reference libraries. Why do I need to add all these jars in the reference library? Because when you're executing it as a Mapreduce program through Eclipse, you will need some of the runtime dependencies, some of the jars which are available through runtime. And that's why you need to basically use those jars which are imported in your project, because then only you can use those runtime libraries. Otherwise, it will throw error that this library is not found. Okay, so we have imported all the libraries because we want to debug through Eclipse. It's nothing but we are running the program through Eclipse only. We are not creating a separate jar or do anything else. We are directly executing your Mapreduce program through Eclipse, and that is the reason why we need all these jars, so that if you start debugging from Eclipse, it may occur that it will throw some error saying that this library is not installed. So to avoid that only, we have installed everything. It's fine. So it's not a performance impact even if you install all the libraries, because as and when you need it, you can use it. All right. So we have imported all the jars. Now what we need to do is, remember in Mapreduce program that we were executing earlier, we were creating an input and output directories. Sorry, we were giving input path and output path which are SDFS path. But if you want to execute this program through Eclipse, you need to create those input path in the local file system. So I'll be creating a new folder under this package only. Let's say the folder name is input data. Okay, so it will create one input data folder. And where does it create that, by the way? So if you want to check the location in the local file system, you need to go to properties, right click properties on the project, go to resource. This is the location where it will create a input data folder in the local file system. Okay, home Cloudera workspace. So what I will do is I will copy the transaction file into the local file system. For example, this is how you do it, right? So you just say cp yeah, so under input data we have a transaction file copied. Okay, as you can see, it is available here. So what I did is I brought the data, input data. I did not put it in SDFS. I brought it back to the local file system under input data directory in this project. Okay, now once I have this data, I can do many things with that. So I can actually run my program to process the data available locally. All right, so let us go and debug this program and understand how do you process the data which is stored in the local file system. Okay, so here, by the way, before I move forward, is everyone clear as of now what I did? Anybody has any questions on this? All right. So let us start debugging this. Basically, I'll put some debug point here. And in this method also, reducer also, right? This is what is called a breakpoint actually, or a debug point. When we put this breakpoint and when we are debugging the program, when runtime when it tries to debug it, what happens? The execution comes and stops at that line. That's how we'll come to know that okay. After that, it will be under your control how to take it forward, and that's how you will be able to understand what's happening behind the scenes. Okay. So I will start debugging it now. I'll show you how to do that. So you just need to right click anywhere in this class file. Just say debug as and go to the debug configuration. Okay. Now here if you go to the right Java applications and start debugging, it says it will have so many options basically. You need to go to the arguments. See in the main class, it says this is a project, this is the main class which I want to debug. We are fine with that. Now in the argument section, see we are always when we create a jar file for Mapreduce, we used to give two arguments, right? Input and output path. The same two arguments you have to give here also. What is an input path? So in this case, the input path is the input data, the directory which you have just created and copied a transaction file, right? So I have to give that transactions. And the output path is, let's say I will create an output directory. I will not create, automatically the job itself will create it. So this is again input and output path which I am setting through the argument sections, right? And I'll just say debug. Now it will start debugging that program. It says input path does not exist. Okay. So looks like we have to check again what is the correct input path that we should have given. This is fine only. Okay. So it was I was capital. I have given it as small. Fair enough. So now we can start debugging it. It was a wrong spelling mistake basically in the folder. As you can see, it says map 7% complete. Basically, we got the debugger at this point, right? All of you can see it here. This green color line which is coming here. So if I go one by one, as you can see, the column 4 is, this is the entire set of columns, and column 4, if you want to inspect, you can inspect it like this. It will give you the actual result. It says exercise and fitness. Okay. So likewise, you can check everything actually. Even if you want to check the value of the column 3, what is it coming dynamically, you can just select and then say right click and inspect. It says 100. So 100 is the value which is coming, right? So this is what you are setting it here. Alright. So likewise, you can go, if you go to the next line, again it will come here. Okay, and here again, if you inspect on, let's say, column 3, it would basically give you some other value. It says 2000, right? So the next record has come. So likewise, you can actually go and debug every record. So see, for every record, it is actually coming like this. Okay. So that's how basically you keep debugging it. Now if I remove that debugger and just press F8, that means the mapper would be completed and it will go to the reducer. Okay, where it says directly the right. So now here the output value is this and the key will be, what will be the key? You can inspect it. Combat Sports and Renault. That's the key and the value will be $279. If I press F8, it will give me the key value for the another record. So again the key would be, let's say, exercise and fitness Honolulu, as you can see here, and the value which is coming here is this 212. So likewise, you can actually debug each and every data which is being processed in your mapper and reducer, right? And you can understand if there is something going wrong, you can easily cache it up. That's the whole idea of using a combiner. Okay. For every product city combination and value, it gives us that data. Okay. So that's it. That's how basically you debug your Mapreduce programs through Eclipse, and you basically find out any issue if there is. So this is how, let's say, your final output is presented. Your output has come. Mapreduce is 100% completed. So let us go and check your output. What is the output that has been created? So if you go here and check, I know some of the people it would become little difficult because you don't know Eclipse and you don't know debugging, but then just understand what I'm doing actually conceptually, where I'm just trying to create, I'm just trying to basically execute a program through Eclipse and try to understand what is happening at every execution, right? So here, as you can see, the output folder will be generated, and if you open this Part3 file, it contains the same output which we have seen through the command line. Okay, so that's how you can debug the programs using Eclipse. Once you understand this, it becomes very handy feature for all of you, because as and when you start writing Mapreduce programs, you will need to debug that also with the data set, so that if there is any problem, you can find out upfront. Right? You don't need to really wait for it to be deployed in production, because before you go and deploy your code in production, you want to make sure that your code will work fine. So this is how you can run it through Eclipse in the local file system. So is everyone clear with this debugging? Any questions? So Santanu, there is a way through which you can enable that, but mostly people use debugger on a single node only, because you want to just quickly test out your program in the local machine and then you want to deploy it in production on a multi-node cluster. Okay. So the testing should happen on a local machine only. As you can see, Mary, there were only two transaction job which executed, which since morning we have executed this program 3 times, right? One with the actual program, one with the debug logger statement. The one job which we have executed through Eclipse did not come on the YAN resource manager. Why? Because we have run it locally. We have not used a normal actual MapReduce production cluster environment. That's why it has not come there. Is that clear? Yes, Vishal. I will be taking all these examples, like how to use a multi-file file as an input, or how to write multiple reducers or multiple output files. So we have just started understanding MapReduce. We will be taking many more problems to understand different concepts in MapReduce. So even tomorrow's session and probably day after tomorrow also, we will just focus on MapReduce programming only. So any more questions anybody has? All right. So this completes the troubleshooting and debugging of MapReduce programs. Okay. Now, as I said, we will definitely take more examples in MapReduce and understand how to solve these problems. We will need to see the partitioner. We'll need to see how do you write multiple reducer. We'll need to see the joins in MapReduce. How do you use custom data types in MapReduce? How do you process unstructured data like XML file in MapReduce? All these concepts we'll be seeing by writing different MapReduce programs. Okay. So that is what we are going to do now. So by the way, what we can do is we can take a break now and we'll come back after the break and continue the session. Is that clear with everyone? Is that fine? All right. So let's take a break. See you all after the break. Hello everyone. So let's continue. So we'll be learning a new concept now, which is basically called a partitioner. Okay. I'll be showing you how to write partitioner, when can it be used, and all that stuff. So let me first show you the example. Example in the sense, let me first show you the data set. This is the data set we have. Okay. And we want to basically use this data set to solve my interesting problem, which is to basically find out the average salary of a permanent and contract employees. Okay. So how do we solve that problem? As you can see here, it's a very simple data. The first column is a user employee ID, second column is employee name, third column is whether he is permanent or contract, and fourth column is what is the salary that he or she is drawing. Okay. That is the problem. That is the data that we have, and based on that, I want to find out what is the average salary of a permanent employees and average salary of a contract employees. So this is the problem I want to solve using Mapreduce. I don't really want to solve only that problem because I want to increase the complexity of a problem to introduce partition concept. But let's start with first a small data set and understand how do we solve that problem, right? So can you tell me what should be the key value if you want to solve that problem? Hello everyone, am I audible? Excellent. Hello everyone, am I audible? Yeah, okay. So yeah, I hope you all understood the problem statement that I'm trying to solve. So I just wanted to understand like what should be the key and value that we should take to solve that problem. Okay, Manoj. So this is the problem statement. I want to find out average salary of all permanent and contract employee. That is the problem statement. Yeah, what should be the key and value to solve that problem? Yes, very good. So that's really good, and I think many of you have given the right answer. That's very good. So the salary, or sorry, the employment type, which is permanent or contract, or you can say employee, job specification, or you can say whether employment type, which is permanent or contract, is the key, and the salary is the value, right? That is correct. So all of you have given the right answer, right? So in that case, let me just open a whiteboard and explain you first. How would it have processed the data? So let us solve and see that. So it will, let me just write it quickly. So it will be something like this, right? You have a mapper code where you will write something like this: permanent 100, permanent 200. I'm just writing some random values. Okay, so let's say this is the output of mapper 1 and this is the output of mapper 2, right? Both of them will be basically combined into the shuffle and sort phase. So it would be something like this: 100, 200, 500, 200, 300, and again 200. Similarly, contract. The reason why I'm drawing all this, because in the partitioner this will also help again. So that's why I'm writing all this. Right. So let's say these are the keys values, and then again, as we know, it will go to the reducer, where reducer will basically take a key and a list of value and then process it. So we will just iterate through these values. We'll find out the average salary, right? That's the code, that's the logic we need to write it in the reducer to get the final output. So now reducer will write permanent comma average salary and contract comma average salary. That is how we will solve this problem. Okay. So anyway, we want to use a partitioner in the same problem, hence we need to program for this code. So let us quickly write a program for this, and then I'll show you how to use a partitioner inside that. So I'll be basically creating a new class, partition. It's actually a custom partitioner. Okay, I'll write out the mapper and reducer code here. So what do you write in mapper? We'll just say public static class not mapper. Now I'll go little fast because we all know all these parameters, so I don't really need to explain you again in detail. But in case when I'm typing anything and I'm programming for anything, feel free to ask any questions if you have. Okay, so I'll not be going through each and every line again, but I'll be just writing the code. I'll also write the input key value pair and output key value pair as a command just to help you understand how the input and output are coming. So I'm just taking appropriate keys and values. Okay, now here this is like how we decide the structure of the program. Then you just create the output key value object. Key value, and then you just need to start using it. So the value I need to convert it into I have to split them based on space. I'll get array of columns. Then I'll set output key dot set columns. What is the third column, right? So it's actually 2, which is my permanent, and value, which is the fourth column. Okay, so that's the mapper code that I'm writing. Similarly, in the reducer code, so mapper code, what I have done, I have taken this entire record, split them based on the space, right? And then I am choosing the right keys and values. The key will be my column of 2, which is what? Permanent, and the value will be the salary, right? And the same way you are writing it as a key value as an output. So let us start writing understanding the reducer code now. We'll write reducer code. Your input key will be what? Permanent. And the value will be the list of values like 100 or 200, 300, 500, something like that. And the output key will be again the permanent. value is the average of all these salaries. So how do you write that? Just a long writable. This is int writable. Sorry, this is text. Whatever is output key value from the mapper, that is what you need to use it as a reducer. So output key value from the mapper is text int writable. That becomes input key value to the reducer. Output also I'm going to write the same way. Alright. Reduce method will take key and list of integers as a salaries. Now I have to take the average. For that I need certain variables to be defined. Now I need to iterate through this salary data. For each salaries, I'm just saying sum is equals to sum plus salary dot object. So I need to get the integer value out of it. That's why dot get. Because integer sum is an int variable. It's a primary. It's a preliminary data type. So hence you need to basically use get to convert it into primitive data type. Average is equal to sum divided by count, and the output key, or sorry, output value that you want to set is your average. That's it. Okay. After that, you can just do context.write key value, and you are done. So basically, this is the code that I'm writing as a reducer code. Okay. So I have completed my mapper and reducer code. Are we clear on this? Any questions as of now? Alright, so since no questions, we'll move forward. So in the driver code, I will not type everything in driver because we have already written a driver code in the earlier job. So let us use that. Let us reuse it. So I'll be just copy pasting the driver code and we'll change certain properties as per our need. Okay. So this becomes partition job. This becomes part mapper. This is your part reducer, right? And so on and so forth. Everything else is the same. This is my entry table. Okay. And this is a partition job. So my driver code is also completed. Now one thing, important thing I want to ask is, can we use a combiner here in this example? Can you tell me if we can use a combiner? Very good, everyone. We can't use a combiner here, right? Because it will change the final output. It's an average. Average of average will not give you the final average, as we discussed earlier. So we can't use a combiner. So let us first try, we'll export it as a jar and we'll execute this program and we'll first see the output. We have not yet introduced a partitioner concept here. We'll first execute this program normally. I need to also check if I have the data available in the SDFS, or I can copy the data. How do you, by the way, copy the file from local file system into SDFS? Remember the the command. Very good, Mano. Yes, Hadoop fs-put. And I think someone was asking me in the morning, earlier morning session, that how do you delete a directory? For example, let's say I want to delete this directory called data, everything under the file also, and I don't want it to be available in some temporary trash folder. I want to permanently delete this. So this is how you do it. Hadoop fs-rm, then space -r, recursively deletes all the directories under the data directory. Okay. Now if you see, the entire data directory is gone, right? So that's how you can do it. Now I can create a fresh new data directory using mkdir command. The reason why I deleted this directory, because there were some lot of files were already put there, so I just wanted to clean it up. So I have deleted it and I'm recreating the directory. Now the data directory is there, but it's empty. Now how do you copy the file? Hadoop fs-put transactions under data. Oh, not transaction, the other input file. Anyway, let it be copied. I'll be using the partition example.txt. Okay. So if you can go here, you got the data here. Now we need to basically execute a jar. So we have already created a jar, mr.jar. We need to give the actual class name which we are going to execute. The partition job is a class name which has your Mapreduce code. So that you need to specify. Why we need to specify this class? Because see, when you are giving a jar path, it may be possible, and that's why I have given you this example, that see, in this jar I have two Java class, maxcell and partition job. So it may be possible that when you create a jar, sometimes it might be the case where you won't be able to, Hadoop framework will not be able to recognize which is the class which you want to execute, right? Because there are two classes here. So in that case, you need to tell Hadoop framework that please use this class as an entry point for execution. Then everything will be fine. Then Hadoop will know that, okay, this is the class he wants me to execute, so let me use it. Part out. Okay. I'm just executing this program. Let's see how does it do that. So by the way, everyone, as we discussed earlier also, till the program gets executed, there is a general practice that simply run request all the participants to follow. At the end of the session, when you close the session, you will get a feedback survey. So please please participate in the survey for all the sessions. It will really help us. And at the same time, as we discussed earlier, there is a community called Simply Talk, a very, very active community and very useful community that has been introduced by Simply Learn. So all of you are, permanent member for Simply Learn family, so you can always use that for any doubt clearing sessions. I mean, it's like you just post your questions and there will be a lot of experts who will be there who can actually help you get your answers. Even if you want some informations other than the Hadoop, let's say other than any other, you might want to ask questions on other technologies, still you can post those questions. So anything and everything under the sun you can ask, and there will be dedicated experts team who will be available who can help you resolve your queries. So it will really help you to gain a lot of information with that community thing. In fact, some participants will also be able to answer some other participants' query, right? So that is also possible. So it's a very good learning forum, interactive learning forum between participants and the trainers and the people. So that way, and in fact, if you have any doubts on, let's say you did not get your video recordings or you had some problem with some of the videos, any such doubts or such issues, you can post your queries in the Simply Talk community itself, or you can mail it to get certified email address. Alright, so this is just an information that I wanted to share with you. Alright, great. So we got the output. Let us see the output first. So we'll go to this data directory. There is a part out directory created. Let us try to see the visualize the output. Hadoop fs-cat part out /data /part out /part r. Okay. So as you can see that we got the output where average salary for permanent and contract employees are printed here. So we are good. We are good and we got the result as expected. Now I want you to tell me one thing, which is this is like, okay, fine, we got the output this way. Now what if, let's say, I want to now tweak the problem. This much I'm sure everyone understood. I'm sure nobody will have any questions on this. If anybody has, let me know. Okay. So this is a simple problem that we solved using Mapreduce. But let's say now I'm increasing a complexity where right now I got all the average salary of a permanent and contract into one file, one output file. What if I want them to be segregated into two output files? For example, I want all the permanent salary data into one file, contract salary data into another output file, right? Basically, I want to segregate the output. So how do you do that? How do you achieve that? So can you tell me what is the bare minimum change we should make, or what is the change we need to do in our program so that we will have two output files generated? Can anybody tell me based on the earlier session where we discussed the architecture? Yes, Shantanu, I was asking a question. What is the bare minimum change you should do? And I was waiting for the response, okay? Okay, so the answer is you need a two reducer, okay? What is the bare minimum change you need to do in your Mapreduce program so that you will have two output files? So the answer is you need a two reducer. And how do you set number of reducers? So in a driver code, just do this job.set number of reduce task as 2. Once you do that, it will automatically create two reducer and the output will be created into two files. Let us see whether just by making this change will be enough for us. So I'll again execute our program. Alright. Everything else will remain the same. We'll just execute a program and check whether the two output files are generated and whether it will segregate the output into a different output files. Yes, Vishal, I think you are right. So basically we need to, it will definitely not going to be, it will not divide the output as per our expectation, but I want you to understand why it will not be able to divide, right? So once we execute this program, I'll also show you the internal flow, what has happened, and then we will understand why do we need a custom partitioner. Alright, so the output is generated. Let us see the output. If you go here and check in the SDFS, you get I think we have not yet, I think it did not reflect. We have to recreate the jar. Looks like earlier it did not. I'll just give part.jar. Earlier program that we executed, it actually did not take effect into the program that we have written. So maybe the jar creation was a problem. It did not reflect the changes. So I had to recreate the jar, and now I'm executing it again. Okay, let us see the output now. So as you can see, one of the output file is empty. It doesn't have any data. If I go to the another output file, it should have had both the data. Right? As you can see from here also, part output 2 has two part R files because there were two reducers. One file was empty, another file should have both the data. Okay. So at least by setting number of reducer as 2, we were able to, create two output files. Yes. As you can see, one output file contains both the records, another output file is empty. Right. So what has happened behind the scenes? So behind the scenes, this is what has happened. So I'll again show you this part where see there were two reducers, reducer 1 and reducer 2. Because you set number of reducer as 2, there will be a partitioner code by default which will run by Hadoop framework. Okay. Always between mapper and shuffle and sort. So that partitioner code, what does it do? It will basically try to, but there is a default partitioner code which will be executed by Hadoop framework on every output key value of the mapper task. Okay. So it will execute it locally, and if there are two reducers, it will create two bucket files. It will be something like this. So what would have happened is, The default partitioner code would create two buckets, and the index for our address of these two buckets is 0 and 1. What do you mean by 0 and 1? So it will be in this range. Okay, it will be like 0 less than or is equal to index less than number of reducer. So it will be 0 less than or equal to index less than 2. 2 is the number of reducer, right? So index can be only between 0 and 1, right? It can have only two values. So whenever you create a number of reducers as 2, it will create two different partition bucket, and the index of them will be 0 and 1 only. It cannot return any other index value. It's a thumb rule. Okay, and it will create this bucket. What is a bucket? Bucket is nothing but a temporary file which is created at a local mapper machines. This is one machine, so there these two files will be created. This is another machine where these two files will be created. Okay, and what it does, it will try to run a partitioner code on every output key value of a mapper. So it will try to segregate them. So here what would have happened is all the permanent keys, right, and all the contract keys would have been written in the same bucket. It was not able to divide them into different buckets. All the keys were, partitioned into one bucket. Another bucket was empty. Similarly for mapper 2 also, all the P and C, all the permanent and contract keys were put under one bucket only, and another bucket was empty. Okay, C comma 100, C comma 200, right? And then what happens is, in shuffle and sort, all the key value of the same bucket will be merged like this, will be combined like this. They will be combined in this fashion, this guy will be, and similarly all the key values of bucket 1 will be combined like this. So that's why we get all permanent and contract combined in bucket 0. Bucket 1 did not have any data, so it's empty. And then what happens? All the bucket 0 key value will go to the reducer 1, all the bucket 1 key value will go to reducer 2, and hence reducer 1 has generated an output file which contains P comma average salary and C comma average salary, whereas reducer 2 has generated an empty result. This is what has happened internally. Okay, I will come to that, Mano. I will explain you how do you create it into separate files. But did we all understand this particular situation? What has happened? So partitioner is a default functionality in Mapreduce which will always run between mapper and shuffle and sort phase. What it does, its job is to basically decide which key value pair from mapper will go to which reducer. If you have more than one reducer, partitioner will do the job of load balancing. Okay, so it will decide if there are 1 million key value pairs are there, then it will segregate some 50% of the key value into one reducer, another into another reducer, right? So that is the job of partitioner. So is everyone clear with this approach, what I have explained? What has happened behind the scenes? We have just set number of reducer as 2, and this is what would have happened. Now how do we make sure that permanent will go to one reducer, contract will go to another reducer? For that we need to override the functionality of partitioner code, which I will tell you how to do that. But is everyone clear with this approach? Any questions on this approach? Alright, so what is the bare minimum change we should do so that they will be given into separate buckets? So it's simple, right? All the contracts and permanent should be given into different buckets. It will be something like this. if I can somehow divide all the contract into one bucket and all the permanent into another bucket, then what has happened? In that case, it would be something like this, right? This is bucket 1, bucket 0. This will go to reducer 2. It will have 0 average. Are we clear on this? What I'm making a change? Everyone? Any doubts on this? What I'm doing is I'm basically making sure that both the... Yes, Nikhil, any question you have? Okay, fine. So we are basically making sure that all the keys of permanent will go to one bucket, contract into another bucket. That's it. Our job is to just make sure that they will be divided into separate bucket. After that, automatically framework will take care of, aggregating them in different buckets in shuffle and sort and given to the different reducer. So that is what we need to make sure. So to divide P permanent into one bucket, contract into another bucket, we need a custom partitioner. So how do you write a custom partitioner? It's a separate class we need to use here. So I'll be writing here, just like mapper and reducer, you need to write a partitioner code, custom partitioner. You can give any name here, by the way, which has to extend partition. Partitioner from Hadoop, which takes key, which is an output key of mapper, and value, which is an output value of the mapper. Okay. And there is a method which we need to override, which is basically called which is just like, in mapper you have map method. In partition you need to override a get partition method, which will take output key of mapper, output value of mapper, and number of reducer as the parameter. It returns integer, which is nothing but an index of the bucket. So let's say I will write a very simple code to divide your key value into separate bucket. I'll just say if okay, see, it's a simple code I am writing. If my key is permanent, then only I'm setting index is 1 and I'm returning it. Otherwise, always index will be 0. So what will happen internally? Whenever you are setting this, whenever P comes, it will be given into index 1. Otherwise, if C comes, it will be put in index 0 bucket, right? So that is how we are making sure that both the keys and values will go to the different buckets. That is our whole idea, right? It may not work for all the keys and values. You may say that this is not a generic code, which is fine. We are not here to debate on how do you write a partitioner code in an effective manner, because the logic will change based on your requirement. But here I am just explaining you how do you use the partition in your framework. Once you understand that, you can always change the logic behind this, and it will be basically you can write a logic corresponding to your requirement. right? So for us, we will just use this as a partitioner logic, and then in driver code, I need to just set what is my partitioner. So I'll just say job dot set partitioner class as custom partitioner class. That's it. This is the change I need to make. So now what I'm doing, I'm making sure that every key value of the mapper will be divided into different buckets based on this logic. If it is permanent, it will go to bucket 1. Otherwise, any other key will go to bucket 0. That's how we'll make sure that two output file will contain two different key outputs. No, set reduce task have to be there. It cannot be removed. Okay. Reducer will still run. So is everyone clear with the partitioner code that I have written? Okay. Now I'll also execute it. So we'll be executing the same code and see what the output comes. All right. So it is generated. Now let us see the output. Now if I try to read the one of the file from the output folder with the partition code, let's see what output comes. You can see one of the file has just permanent average salary. Another output file should have contract average salary. Okay. So that is how we will be able to segregate the output into different output files based on the partitioner code. Okay. So that's the use of partition in Mapreduce. Now this concept can be used in many other situation in real world example, like you have credit and debit card fraud transactions. So based on transaction you want to identify whether it's a credit or debit card fraud. So in that also you can use a partition and divide all the credit card transaction into one file and debit card into another file. So likewise there are so many other applications where you can use a partition. So it's a very handy use case. It's a very handy concept which can help you to solve so many problems. Okay. So is everyone clear with the partitioner code? Any questions anybody has? Okay. Yes, Nathan, of course. So you can always see, as long as you understand concept and how to implement it, the volume of data really doesn't matter much, because you can execute the same program on large volume of data on a larger cluster and it will work the same way, right? So if you understand the concept, if you can implement, I'm sure you can do this with a large data also. There is no difference there, right? So that's all I had, guys, for today's session. That's what I wanted to cover. So we'll meet tomorrow at the same time and we will discuss few more interesting Mapreduce concepts, some of the advanced concepts of Mapreduce. So anybody wants to have any further questions before we close the session? No problem, Mary, go ahead. Nitin, this is not the last week. Okay. I think there was some communication gap and the session will be for 7 more days. So yes, even I got to know just last week. So we will have 2 more days extended. So this week 5 days plus 2 more days. That is the time. So I think we need to check with Simplilearn team. They need to resend you the new invite. Okay, Mary. So that is called autocomplete feature. Okay. In Eclipse, whenever you are typing any word, it will actually give you autocomplete. If I type control space, it will give you the full word. You don't need to type everything. It's an autocomplete feature of an Eclipse. Okay. You need to type control space after typing 2-3 characters of that word, and it will automatically give you the full word. All right. So is everyone able to understand, right? I mean, anybody has any problem, any questions? All right, cool. So I'll send an email, Nitin, on that. Okay. All right, everyone. Thank you so much. Have a good day, and please fill up the feedback survey at the end of this session. So thank you, everyone, and have a good day. We'll see you tomorrow. Okay. Yes, Olga, it is extended for 2 days. So that's what I got to know from one of the Simplilearn coordinators. So I don't know whether they have made it as formal or not. So I cannot still confirm on that, by the way. So it will give you the email. All right. So see you, everyone. Olga, please check with Simplilearn team. You need to write a mail to get certified at Simplilearn. They will help you on that. All right. Okay. See you, everyone.